right, this video is for homework 9. We are doing natural logs. So, to just kind of, I don't want to do it that way. Yep, go for it. Okay, so these are written, the e in these is not an exponent or not a variable. It's like pi. It's like using the pi symbol, okay? In your calculator, you can find this. It is right here to the left of the 1. You see the e to the x. You can do e to the 3rd. We're not solving these. We're rewriting these, but I just want you to see where to find, these pieces. That's the e that you're looking for, okay? So if we want to write them as a logarithm, we write them as a natural log, okay? So we can convert them the same way that we did the other ones. So if we write log, and then remember the base stays the base, and then whatever it's equal to becomes the argument, and then the exponent is what it's equal to. But we don't write log base e. This is called a natural logarithm, and so instead of log e, we write ln. A natural log. I know it's backwards.
Wait, so we don't write log either?
Nope, ln, a natural log. Log to base e is called a natural log, ln. And then that equals 3.
So our final answer is 3?
Well, this right here, this is it converted. Okay. So one that's got multi-steps to it. So again, if you need to write log e first and then go back and change it, that's completely fine. Okay, so convert it to a log, and then anytime you have log e, you change log e to ln.
What do you do with the 9 though?
Nothing. You leave it there. We're not solving. We're just writing them in logarithm form. That's all we're doing. All right, so to go the opposite direction. So if you need to expand, if you see that, go ahead.
What does ln mean again?
Natural log. It's a natural logarithm. So if you need to expand an ln to a log e so you can see all your pieces so you know what you're doing. Yes.
Are you sure it's not NL?
No, it's ln. I'm positive. All right.
Why do they gotta make it more confusing?
Welcome to math. All right, so if we want to go the opposite direction, so remember the base stays the base. What it's equal to becomes the exponent, and then the argument switches sides. I expand it. If I see a natural log, I rewrite it as log e, so I can see all my pieces, and that makes it easier for me to rearrange. So let's look at...
So the second one, we're just changing the natural logs to the e of x again.
We're changing them back to exponential.
Yeah, we look at number 5. Sorry, so not 6.
I'm going to do 6. So log e 87 equals x plus 4. All right. Base stays the base. What it's equal to becomes the exponent. The argument is what it's equal to. So just, you can have a bunch of crazy junk up in there, up in your exponent. So the rules for condensing are the same. Okay? So same base, ln and ln. That means I have the same base. If we're using addition, we can multiply the arguments. So 4 times 3x is 12x. Okay? Coefficients, same rule applies. So if I want to move that coefficient out of the way, I can make this to the 1/2. And then I can move this 3 up here.
Is it going to be a negative 3 or just a 3?
It's just a 3 because we're subtracting 2 logs.
Okay.
Okay? All right. So if it's subtraction, we can divide these. Okay? So we would have 256 to the 1/2 over 2 to the 3rd. And then, oops, sorry. then you can just do just this piece. Simplify that down to the, oh, stop it. Try that again. To the 1/2. Remember, 1/2 is the same as squaring it. So we get, that simplifies to a 2. So this whole mess simplifies to a natural log of 2.
So
Oh, ln2, sorry, you can't see what I'm doing. Sometimes you can't simplify. Like here, when you do the division, it's going to stay in this form because there's no like terms to combine. All right, going the opposite direction. Okay, so now we're expanding. So what we're multiplying here is 2 times m to the 8. Those are the two things that are being multiplied here. So I can do ln 2 plus ln m to the 8. And if I want to expand again, I don't want this exponent here. So I can make the exponent a coefficient. And for some of these, especially with the natural log, since that lowercase l looks like a 1, you may want to put, when you're writing coefficients, put that dot in between to signify that you're not writing 81 in, that you're writing 8 natural log m. All right, if they're dividing, so first we've got to get rid of this 3. Okay, power to a power rule.
Does it have to be a lowercase L, or can you make it a capital?
Technically, it's supposed to be lowercase. I'm okay if you want to make it capital to signify that it's an L and not a 1. Okay. All right. Power to a power, you multiply them. 5 times 3 is 15. So now we got an n. 2 times 3 is a 6. All right, if we're dividing, that means these are being subtracted, or by expanding, I can write them with subtraction. And then move your exponent, or yeah, move your exponents, make them coefficients. All you're doing is moving pieces around. Okay, a square root is the same thing as raising this entire thing to an exponent of 1/2. I do that so I can simplify exponents before I do anything else. So 8 times 1/2 is a 4. 5 times 1/2 is a 5/2.
What is that little bill you just drew?
That is a lowercase s in cursive. I was taught in math classes that you don't write lowercase s because it looks like a 5.
True.
That you do it in cursive. Same thing with cursive s. Up, down, over. Same with z's. If you see me cross my z's, it's because lowercase z's look like a 2. Do what you can. I can tell that I'll be able to tell the difference on your page.
Ms. Stalling,
Yep.
should we take the Module 10 quiz today or tomorrow?
I put the module 11 on Friday. So if you want to take it tomorrow, I say you've got time to take it tomorrow and still have days to study for module 11.
Okay, I'll do that.
Okay. All right. So if we're multiplying, because r to the 4th is being multiplied by s to the 5/2. Anytime you're shoving something together, it's multiplication. So we can expand it with addition. And then get rid of our exponents by making them coefficients. And this one's got everything. So you know how these were each lessons for logarithms? we're solving on this one too. So pay attention when it's telling you to do expand, condense. Down here, it's telling you to solve. The rules are the same. If the bases are the same, I can set the arguments equal to each other. And then at this point you can do menu 3-1, 9x minus 7 equals 5x plus 33, comma x equals 10. Also make sure that your 10 doesn't make it negative. So 9 times 10 is 90, minus 7 is 83. It's positive. So same rule with logarithms. Your argument can't be negative. Yes, sir.
Since our natural logs aren't really even used, like why do we put that L in front?
Instead of writing log E? Is that what you're asking?
Yeah. No, why don't we just have the equation? Like just the equation. Why does there have to be an L in it?
So you know the rules when you see that. Because they're not always going to be just straight up nice and pretty.
Yeah.
So like this one, right? My bases are the same, but see now I've got exponents involved. So I can set the arguments equal. Also, Kenny, our calculators, the Inspire, will solve logarithms of any base. The 84s will not. So you have to know how to convert them and how to convert to base 10. So that's one thing that you guys don't have to worry with, change of base formula, because your calculators will do any base. Okay? All right. So here, what I want to do, I want to get my x squareds together first. So I'm going to subtract x squared from both sides. So that's an x squared. All right. If you have a situation like this, there's no x term here. There's no 3x, just a plain x. Huh?
Why didn't you put the 2 back in front of x?
Because 2x squared minus x squared is x squared. So on this one, I don't have to use quadratic formula. I don't have to graph. If I can get the x squared by itself, so by doing that, I need to add 15 to both sides. X squared cancels. 34 plus 15 is 49. Now, all I have to do, find a different color here that'll stand out. Yeah, I can square root both sides. So the square root of 49 is positive 7 and negative 7. Remember, square roots have 2 answers, the positive and the negative. And then check them. Check them to make sure. So 7 squared is 49 plus 34. That would be positive. Negative 7 squared. All right.
No.
What's happening, I think, is you're doing this. You're doing negative 7 squared and then plus 34. But it should be that negative 7 needs to be in parentheses. Anytime you swap a letter for a number, it needs to be in parentheses because it does affect your answer. Okay. This first one, what this means is 7 squared, and then you're multiplying by a negative 1. Okay. This one means negative 7 squared, which is negative 7 times negative 7. Negative times a negative equals a positive. That negative falls away. So be really careful when you're checking answers because both of these are valid answers. They're good.
Hey, does that mean journals are going to be this week?
Probably next Monday or Tuesday.
Next Tuesday. Let's go Tuesday.
It depends on when we start the test. If we start the test Friday, they'll be due Monday. They'll be... All right, so let's look over the back. Let's pick out some of the hard ones to do together.
Let's do 15 through 24.
How about you do 15 through 24?
No.
How about we do 15 to 23 then?
Pick some of the hard ones. Just look over them and somebody throw one out. I'll work about half
20.
of them.
16.
Wait.
20, 21.
Wait. 16, 18, 20 were the first ones I heard, correct?
And 24.
Nope, you already picked one.
No.
24. Brody, pick 24.
24 has already been picked.
23. Brody, pick it.
22. All right, I'll work the evens. Okay. We have got to combine. We've got to combine here because I can only have one logarithm on both sides. So if it's addition, we multiply. 8 times n is 8n. 8 times negative 9 is negative 72. And then I want to move this 5. So 2 to the 5th. Bases are now the same. So I can set them equal to each other. Do we know what to do at this point? Menu 3-1. Can I leave the menu 3-1 part for you guys? Okay. That one's a menu 3-1. All right, we've got to combine here because I've got 2 logarithms. So if it's subtracting, it's division. And that equals 2. If it's equal to a number, just like logarithms, rewrite it in exponential form. Okay, so base stays, 2 becomes your exponent, equals k over 14. So e squared equals k over 14. So here's what I'm going to do. So I'm going to do e squared. E squared, whoa. E squared gives me that. How would I get this 14 off the bottom? Times 14. So k equals 103.447. So I worked this piece out in the calculator, and it gave me 7.38906 equals k over 14. At this point, it's inverse operations to solve, or menu 3-1. It's just, if you menu 3-1, you've got a lot of stuff to type. All right, negative 2 e to the c plus 14 equals negative 6. I want to get this 14 away. I want to have just the e over here.
Minus 14.
Okay, so we're going to minus the 14. Negative 2 e to the c equals negative 20. Okay, now I want to get the 2 away from the e. Divide by negative 2, divide by negative 2. I'm going to move this way. So this cancels. E to the c equals 10. Okay. Well, no, because I got to solve. I got to solve for the c. Remember, the e is like a symbol. So this one I'm going to rewrite as a log. So log, this is my base, this is my argument, equals c. But I need to do ln, replace this. Now, here's why you need to replace that. You can't do log base e in your calculator, but you can do ln. So control, and then that same one that gives you the e, and then all you have to do is put a 10 in there, and that's your answer. 2.3025. 9. Okay, 22. Let's move everything away from the E. So what do I need to move first?
The 3K or the 4?
The 1. PEMDAS backwards. Okay, now what needs to be moved? So divide by 4. So e to the 3k equals 84 divided by 4 is 21. I think 21.
Yes.
Okay, rewrite it. So if it's e to a number, you can solve it. If it's e to any kind of letter, you need to rewrite it. So this is ln 21 equals 3k. So this part I can do in my calculator. ln 21. And then what would my next or my last step be?
How'd you do that, ln?
Control and then the e to the x button.
Times 3, whatever.
Not times.
Divide by 3.
Divide by 3. Because in the end, you need the letter by itself. All right, 24, get the e by itself. So what gets moved first?
The plus
Let's
8,
say-
I mean the 8, so plus 8 to both sides.
So 3e to the 4m minus 7 equals 106 plus 8, 114. Okay. How do I move that 3?
Divide.
Divide by 3. So e to the 4m minus 7 equals 114 divided by 3's 38. Rewrite it because the e has an x as a variable in the exponent. So this is ln 38 equals 4m minus 7. All right, so this piece first. ln 38. Okay, so I've worked this out. What gets moved first over here away from the m?
Plus 7.
Plus 7. Okay, so that's gone. And then what's left to do?
Plus 7 to the 38.
Already did that.
Divide by 4.
Divide by 4. So m, and again, at this, once you solve this piece in the calculator, you can menu 3-1 it. M equals 2.6594. Actually, I'm curious if you can menu 3-1, if you can put the thing in like this, 38 equals 4m minus 7, comma m. If you can get it to this point, you can menu 3-1 it. So if you can get the e by itself and then convert it to logarithm form, you can menu 3-1 it at that point. Okay. What do we got left time? 20 minutes. Let's get some of these other ones at least set up for you.
Did we solve 18 together? Or was that we need 3-1?
Nope, we solved.
Wait, can you show me 24 one more time?
Okay, good. All right. So, subtraction. You combine using division. So, ln 60 divided by 4 equals ln x squared plus 2x. 60 divided by 4 is 15. So, I'm just going to mark it out and do 15. So, 15 equals x squared plus 2x. This is a graphing one. So, I want to move the 15 over here. And then I can graph it. All right, x squared plus 2x minus 15. Menu 6, 1, negative 5, and positive 3. X equals negative 5, x equals 3. So negative 5 squared would be 25. 2 times negative 5 would be a negative 10. 25 minus 10 would still be positive, so both are good answers. All right, convert to exponential form. Remember, just a number. So e is my base, 5 is my exponent, equals 4w plus 9. So, do e to the 5th and then move everything else away from the w. If there's a variable in the exponent, convert it to a logarithm. And then all you have to do is type this in and that gives you your answer.
Wait, is 17, is that a menu 3-1?
No.
Is it a graph?
No. It's a type this in and then get rid of the 9 and get rid of the 4. Okay. Variable in the exponent, so we need to convert. Actually, we need to move stuff away first. So what needs to get moved away from that e? So add 27. So we've got E, is it a Y? Y minus 1 equals 81. So log E 81 equals Y minus 1. Convert to a natural log. Type this in. And then add 1 to it. All right, last one. What needs to get moved away from the E? So subtract the 2 from both sides. Convert. L into. Type this part in. And get rid of the 5 and the negative 2. Okay. All right, so that leaves you a couple. You've only got a